Hey everybody, it's Dr. Osborne. Welcome to a special Friday edition of Pick Dr. Osborne's Brain. I took Monday off if you couldn't tell, but I'm happy to be back this Friday with more great information for you. Today's topic we're going to be diving into is about B vitamins in particular. I'm going to be talking about 3 B vitamins today that can contribute to a host of different types of problems, including Alzheimer's disease, neurological problems, heart disease, bone loss, you name it. These B vitamin deficiencies are major issues why so many people have chronic illness in today's society, and we're going to be diving right into them. Before we get in though, I want to just see who we've got on the phone, on the line today. So if you are new to the Dr. Osborne Show, the Pick Dr. Osborne's Brain Show, let me know where you're from and say hello. I want to know how far we're reaching. So far we've got Maxine from Pennsylvania, and Anne-Marie Agros. You're not telling me where you're from. Where are you from, Anne-Marie? And Misty Rushing from Scleroderma Functional Medicine Group. Hi, Misty. Good to see you here. And we've got Emily from Cypress, Texas, and Dorothy from Illinois. Chris, don't know where you're from, Chris, but welcome to the show. We've got Lori. Happy Friday right back to you. We've got Dorothy from Pensacola, Florida. Keep coming, folks. There's a lot more of you who aren't chiming in yet, so just keep coming. I want to see where you're from in the world. And if you've got questions, please, I can only answer so many within the time we've got allotted for the show. So if you want them answered, it's first come, first serve. Go ahead and start typing those questions in, and I'm going to do my best to get them answered before the show is over tonight. And again, those of you who are new, you can check out our archives. Go to youtube.com/glutanology, and you can check out all of our archive shows there. You can also get more information about our mission, helping 100 million chronically sick people find real answers to their health problems at glutenfreesociety.org, as well as drpeterosborne.com. So again, welcome to the show. Today's topic is going to be all about B vitamins. Now, today we're going to focus on a few. We're going to start with vitamin B12, and we're going to roll out with folate, which is vitamin B9, and then we're also going to be talking about vitamin B6. And one of the reasons why we're talking about these 3 in conjunction is because they all share kind of a similar role in the body. They all take care of a chemical called homocysteine. And I want you to understand this is a very important thing. And the reason I'm having this show today is because there's a huge takeaway clinically that you can go to your doctor and you can really get some great information with a simple lab test. That lab test is called homocysteine. So take note of that, because I want you to be able to get this information analyzed once you've read about it, heard about it, and make sure that you have access to this beneficial test that can be run. It's a simple lab test. So homocysteine is an independent risk factor for Alzheimer's or dementia. It's an independent risk factor for heart disease. It's an independent risk factor for nerve damage or nerve hypoxia. It's been linked to diabetes. It's also been linked to bone loss. So it's a very important chemical with a central theme. And those of you who've been following me for any length of time might have heard the term methylation. Homocysteine is a molecule that is central to a process in our body. It's a detoxification process called methylation. And so homocysteine, very important metabolically speaking, and if we have the capacity to measure it, we can get a lot of great information about whether or not we have these B vitamin deficiencies. So let's back up just a minute. I want to talk a little bit about vitamin B12. Vitamin B12 comes from animal foods, and so vegetarians oftentimes have an increased risk for vitamin B12 deficiency. So those of you who may be following a vegan diet or a vegetarian diet, it's very important that you ask your doctor periodically to check your vitamin B12 levels. Some people are suited for veganism or suited for vegetarian diets, and some people are better suited for meat diets, and that's why there's 2 sides of the fence. You've got vegans and vegetarians that claim how much better their health are when they're following that diet. You've got people who eat lots of animal meat that claim how much better they feel when they eat that type of diet. It's because there are genetic differences amongst people, and some people are better suited for vegetarianism and some are better suited for meat. But it's very difficult to get the quantity of vitamin B12 from a vegetarian diet. So vegetarians, it is one of the risk factors that you have. So just keep that in mind. It's a very simple thing that you can do to have your vitamin B12 levels measured. One of the ways you can do that is through homocysteine. And one of the ways you can also do that is to ask for intracellular vitamin B12 level testing done through your doctor. Now, vitamin B12 deficiency can cause depression and it can cause fatigue. Those are actually the two most common symptoms that we see associated with vitamin B12 deficiency: depression and fatigue. Depression, in part because of homocysteine. Homocysteine elevations can actually contribute to depression because of why? Because it can cause nerve damage, and depression oftentimes can stem from brain imbalances or biochemical imbalances in your brain. But vitamin B12 deficiency, also very, very important that you understand that it can cause anemia. So if we're looking at, what are some of the things that vitamin B12 deficiency contribute to? The big ones: fatigue, depression, and anemia. So if you're tired, if you're lethargic, if you've lost your ability to focus and concentrate, if you feel blue, sad, you don't know why, there's no real reason why you're feeling depressed, and if you're short of breath, anemia, one of the big symptoms of anemia is shortness of breath. You're not getting enough oxygen because your red blood cells are not developing. Vitamin B12 deficiency plays a role in all three of those types of conditions. Now, one of the other big ones is nerve damage. And so nerve damage, when I say nerve damage, let's define that as really as neuropathy, which is kind of the symptom can be numbness and tingling of your hands and your feet. A lot of people really start to develop burning or numbness and tingling in the feet as one of the progenitor symptoms of vitamin B12 deficiency. So if you're experiencing any of those things there, you should be suspecting a possible vitamin B12 deficiency. Okay. In addition, it's important to understand that, again, animal-based foods, animal meat is where you're going to get a lot of your B12. Now, some vegetarians will use like supplemental yeast, and some will take like algae-based products that can contain some B12, but those are somewhat harder for the body to metabolize. So again, animal meat is the best source, hands down, in terms of quantity of B12 in the human diet. And if you're vegetarian, yeast or algae, but also supplementation can be very helpful. So just the key is, again, check your levels periodically to make sure that, again, these things aren't happening. There have been some studies that show that even in the vegetarian-based diets contribute to nerve damage in that way as a result of an increased risk for the development of vitamin B12 deficiency. It doesn't mean those of you who are vegetarians are guaranteed to become nerve damaged as a result, but again, it's just important to know that so that you can get the proper testing done to make sure that that's not going to happen to you. So animal meats, yeast, algae, fatigue, depression, anemia, nerve damage, all symptoms of vitamin B12 deficiency. And some people also ask, what are the best ways to take vitamin B12? If you're going to take supplemental vitamin B12, there are different forms of vitamin B12, and some of them are created and are better than other forms, but there are four primary forms, and I'm not going to get into the chemistry of that today, but methylcobalamin, hydroxocobalamin, adenosylcobalamin, and cyanocobalamin are the four primary forms. If you're taking a product or supplement and it says cyanocobalamin, so if you see that word cyanocobalamin, C-O-B-A-L-A-M-I-N, that's not the best form. That's actually the cheapest form, and that's why a lot of your supplements contain it. But it's harder for the body to utilize. It's harder for the body to assimilate. If you're really looking for quality vitamin B12, methyl and hydroxy are two of the best forms. As a matter of fact, some studies show that hydroxy works better actually at getting B12 into your system than getting an injection of B12. So those of you who do vitamin B12 injections and you don't want to stick yourself with a needle, consider a solid hydroxocobalamin in a sublingual form, because in a sublingual form, the vitamin itself absorbs in your cheeks through your cheek mucosal cells into your bloodstream directly. So even if you don't make intrinsic factor, many of you with gluten sensitivity have damaged stomach linings, so you don't make the substance called intrinsic factor that's necessary to absorb vitamin B12, and so you can develop vitamin B12 deficiencies. This is actually one of the most common deficiencies in gluten gluten-sensitive individuals for that reason, because gluten can damage the special type of cell that helps you absorb vitamin B12. So taking that sublingual, especially in a hydroxocobalamin form, works as effectively as an injection, but it bypasses intrinsic factors so that you don't have to worry about whether or not your stomach is damaged to the point where you're less capable of absorbing vitamin B12. So that's the breakdown, quick breakdown on vitamin B12. We could actually write a textbook on B12, but we don't have time in the show to do that. Let's talk a little bit about folate, vitamin B9. Folate, or some people refer to it as folic acid, although that's not technically correct. Folic acid is a synthetic version of folate, which is used to fortify the foods in the United States, particularly a lot of your packaged foods, and all grains, so like your breads, your pastas, your cereals, things of that nature, are fortified with folic acid, not folate. And so actual folate is the natural form of this vitamin, not the synthetic form. So when you're looking at supplements, you want to make sure you're getting either like a methylated folate, a methylfolate, M-E-T-H-Y-L, methylfolate, or something like a folinic acid. Those two are better forms in terms of supplementation if you're using folate in supplement form. But folate has several functions, and some of those functions play a role here. Let me change colors. I'm going to draw some more arrows here. So folate plays a big role in a process called methylation. And methylation, in a nutshell, helps us to produce nerve chemicals. Serotonin is one of them, and dopamine is another. Now, most people think this is important for brain health, and it is, but understand that 90% of serotonin is in the gut, and about 60 to 65% of dopamine is produced in the gut. So folate is extremely important for gut cells to be able to function, to help create a healthy microbiome, to be able to help you produce these neurotransmitters. You need it in the brain too, but very critical in the gut. And the gut talks to the brain, and this is why some people with folate deficiency can actually develop as well depression. There were some studies done a number of years ago, probably over a decade ago at this point, where they were using antidepressants, the SSRI medications, and they were using them without folate, and found that they were not as effective. But when they added folate to the medication, they found a synergistic effectiveness. And one of the reasons why, again, is that folate helps you produce serotonin. The SSRIs as medications only preserve the serotonin that you're capable of producing. So if you're not producing your own, but you're just preserving it, that doesn't really serve you. You want to be able to produce your own, and that's where folate plays a critical role in metabolism. Now, folate deficiency can also, again, it can cause an elevation in homocysteine. We need folate to metabolize homocysteine. And again, I'm going to show you about that pathway in just a minute. So the other thing that folate is very important for is gut function. And one of the things that folate is necessary to do, and that's through the DNA and RNA replication. So you need folate to make new DNA and RNA. And why this is important for gut function is that the gut has a 2-day life cycle. So the cells in the GI tract only live for about 2 days before they have to be replaced. And in order to return over cells that quickly, you've got to have adequate levels of folate driving DNA and RNA replication in your gut cells to make new gut cells. So when folate levels start to drop, gut function starts to drop. This is one of the reasons people who are on chemotherapy, like cancer-based oral chemotherapy agents, one of the ways those drugs work is they actually block the metabolism and the actual function of folate. If you've ever heard the drug methotrexate, which is a very common chemotherapeutic agent, it's also used in painful diseases like rheumatoid arthritis and lupus and scleroderma to subdue the pain. Methotrexate is. It's because it blocks folate, and again, the outcome of that is damage to the gut. It actually can help with the development of leaky gut. So folate is very important for normal gut function, very important for normal brain function through the production of neurotransmitters, also very important for gut motility, but also very important, again,
it's because it blocks
folate. So you can see some overlap between the functions and the signs and symptoms of these two vitamins, vitamin B12 and folate. And there is a lot of overlap simply because B vitamins generally play together. They generally help each other do similar jobs. Now, from a diet perspective, if you're talking about getting folate in the diet, one of the best sources is green leafies. So get your green leafy veg, things like spinach and chard. Now some people that are gluten sensitive and have gut damage don't do well with green leafies. They don't digest them well. One of the things you can do to improve that and still be able to get your green leafies and your folate is to steam those vegetables or cook them down. And that makes them easier to process and digest if you're struggling with digestive problems. So green leafies, great source of folate, as is liver. Liver is one of the best sources of folate. So if you can bring yourself to eat liver, some people hate the taste, the texture, they didn't grow up with it, but if you can bring yourself to eat liver, it's a good source of folate. It's also a very good source of vitamin B12. So again, B12 and vitamin B9, crucial, share a lot of similar functions. Let's go into vitamin B6. Now, vitamin B6 is super, super important, and some of the reasons why it's so important: it plays a central role in how your body breaks down protein, carbs, and fats. Now you've probably heard, the old saying, people talk about B vitamins being good for energy. And where do we get energy from? Well, we get energy from our macronutrients, our proteins, our carbs, and our fats. So we eat those foods, they're broken down into our GI tract, and then we absorb them into our bloodstream. From our bloodstream, the smaller protein amino acids, the smaller carb molecules like glucose, and the fats, the different types of fats, get shuttled inside of our cells, and it's inside the cell where vitamin B6 actually works to help your body break them down and convert them into energy. It also helps to convert proteins, different proteins, into or amino acids into different neurotransmitters. We need vitamin B6 for serotonin as well. So folate, again, there's some overlap here. We've got B6 in this process, right? Overlapping. We've got vitamin B6 is also necessary to help your liver detoxify. One of the things B6 does is it aids that methylation process, or actually it's transsulfuration, but we're not going to get technical into that type of stuff. But so liver detox, vitamin B6, very important. And then another overlap, actually this one, we'll just draw a line, is that vitamin B6 deficiency can contribute to anemia as well. Now there are different kinds of anemia. Most of you have probably heard of iron deficiency anemia. It's one of the more common types. But vitamin B6 and vitamin B12 and folate, all of these three together, there's actually a job. We're running out of room here. There's a job that they all have. And that job is to help the bone marrow. So your bones, this is my bone, don't make fun of my drawing, but you have marrow inside your long bones, and inside that marrow you have stem cells, and those stem cells are progenitors to producing red blood cells. So they help you make red blood cells, and when red blood cells are born, they're typically very large and they're nucleated, meaning they have a central nucleus inside the cell. But as red blood cells mature, they actually get smaller, and they get smaller, and then they lose their nucleus, and they take on this discoid-like shape. And it's here, right here in this concavity, that's where we bind oxygen. And inside that red blood cell, you trade it out, the body trades out the nucleus for a iron-containing protein called hemoglobin, and it kind of looks somewhat like this, and that's what attracts the oxygen and the carbon dioxide to the red blood cell. What happens, though, is for this process to occur, up here you need vitamin B12, down here you need B12 and folate. To form hemoglobin, you need vitamin B6. So you need all three of them at different components along the way toward forming red blood cells so that your body carries adequate oxygen. And that's why, again, all these B vitamins play with each other. They play together, serving similar functions and similar roles. And that's why they have similar side effects when you have deficiency. So, for example, vitamin B6 deficiency, just like folate and B12, can cause fatigue. Okay, and it can cause anemia, and anemia-based fatigue, meaning if you can't deliver that oxygen to other cells, to your brain cells, to your heart cells, to your muscle cells, you don't make energy as efficiently without oxygen. It's a rate-limiting step for the conversion of your nutrients into ATP, which is what the body uses to produce or to generate energy. Then that leads to problems. That leads to lots of fatigue. So these three B vitamins super, super critical, lots of functions. Where do we get B6? We get B6 from a lot of foods. Most foods will contain some B6. But where we tend to find people deficient in vitamin B6 is when, again, this is another one just similar to B12, but not quite as bad, is that we get a lot of B6 from animal-based foods. And we also get B6, there are some vegetarian-based foods that we get B6 from as well. But B6 generally tends to be deficient in people who, again, have other B vitamin deficiencies. So one B vitamin plays off the other. When you become deficient in one, the other ones have to work harder to try to compensate for that deficiency. And so generally when we see B vitamin deficiencies, we see them in clusters, we see them in groups. People that have a hard time or have a big detoxification issue as well, or they're being exposed to a lot of heavy metals or being exposed to different environmental toxins, have a greater tendency toward vitamin B6 deficiency. Because why? Because we said earlier that it plays a role in liver detox. So we're going to pause there for just a second. Okay, we got lots more of you chiming in. We got Ruby from Nevada and Elizabeth Rodriguez from Brooklyn and Lori from Arlington, Texas, Ann from Pennsylvania, Dorothy from Pensacola, Wanda from Tennessee, Tracy Elizabeth, Nola, and Ronnie from Sugarland, right here in my backyard. Fantastic. We got Jane from Australia. We've got a lot of you chiming in now. Thanks so much for letting me know where you're from. That makes my day to know we're reaching so many people across the world in so many different areas. Okay. Now, let's talk a little bit about kind of the theme of today's show, which is this homocysteine. Now again, remember that homocysteine can be measured in the blood. It's a simple lab test. Most doctors, even it's not one of those like in functional medicine, some of the lab tests that we run are pretty advanced, and a lot of doctors are like, never heard of that before. Homocysteine is a pretty common test, so you shouldn't get your doctor looking at you like you're funny or like you are crazy when you're asking for homocysteine. It's a pretty standard lab test these days, because of its independent risk factor association with all of these different conditions. But I want to make a little bit of room here. I want to talk a little bit about how homocysteine is kind of a central theme that plays a lot of different roles in your body. So homocysteine has to be metabolized. And one of the ways that we get rid of homocysteine, because everybody makes homocysteine, so it's not a bad chemical, it's not a bad guy, it's actually, we all make it, it's like an exhaust product, if you will. And the way we get rid of it is we have a couple different pathways where our body can basically convert homocysteine into other types of chemicals. And these different pathways require different B vitamins, and that's kind of what we're going to be talking about here. So one of the pathways, one of the exhaust pipes, if you will, for getting rid of homocysteine is to convert it into a substance or an amino acid called methionine. Now, methionine is super important in methylation. This is actually, when doctors talk about methylation, this is kind of the central theme of what methylation is all about. Methionine is what helps us to produce new RNA, new DNA, new protein, new fats, so that our body can heal, repair, maintain itself. And without this conversion, it's harder to get to this end result, which helps in your body's maintenance. So when we build up, this is one of the reasons why it's linked to so many different conditions, because we get a reduction in the capacity to get to this point, and that, again, that leads to an inability for our body to maintain itself. So when cells get old and they have to be replaced, again, that requires new protein, new fat, new DNA, new RNA to make that new material. And if we don't convert homocysteine properly to get to here, then that can be hindered. One of the other ways we get rid of homocysteine is through converting it to cysteine and then subsequently into a substance called glutathione. Now, you've probably heard of glutathione before. Glutathione is what the liver uses for detoxification. So coming back over here, think of glutathione as the master antioxidant for liver detoxification. So one of the important roles of homocysteine is that we convert it to cysteine, and cysteine is a precursor to helping to produce glutathione. Now this may be getting a little sciencey and techy, but a lot of you have maybe heard of the supplement N-acetylcysteine And that's what this is referring to. Doctors oftentimes will give NAC, N-acetylcysteine, to help the body produce glutathione. So again, this is part of that pathway. But one of the other things that cysteine helps do is it helps form bile acids. And bile acids are super critical for several things. One, for fat absorption. We need bile acids to emulsify fat when we're eating fat in our diet so that we can absorb that fat. Otherwise, we poop it out and we have fat malabsorption. So bile acids are important for fat absorption, but bile acids are also important as binding agents in the GI tract. They actually help us to detoxify. So you need bile acids for detoxification. You need glutathione for detoxification. So you can see if we build up this homocysteine and we're not converting it north and south to methionine and cysteine and bile acids and glutathione, what ends up happening is not only does the homocysteine directly damage our tissues, because that's part of that disease association is that homocysteine is toxic to these tissues, so it can directly damage them. But the other part is we become less efficient at producing these other very, very important and critical metabolites that help our body heal, maintain, and repair. And that's one of the reasons why we want to know what homocysteine is, because if you know what homocysteine is, if you measure it, if it's too high, and so those of you, when you get a homocysteine test back, you're really looking at your homocysteine levels. You know, when you get your numbers, is usually a scale, and that in most labs report that elevations in homocysteine are anything really greater than 15, but you really want to look at being under 9. Somewhere under 9 is going to be more ideal. That's going to get you, again, affecting all of these pathways ideally. So, okay, let's go back to comments here. All right. Sorry, my phone is slower than me. Let's see if we can pull them up. All right. I'm getting fits here. Okay, it looks like we got a few questions coming in here. Maxine's asking, is it a DNA test that tells a person if they do better on a plant-based or animal-based diet? Yes, in a sense it is, Maxine. There are a number of different tests that help us to discern that. It's not particularly one test. Chris is asking, do you lower homocysteine by taking the B vitamins? So now we're thinking, right? That's a great question, Chris. Yes, as a matter of fact, you can. In essence, if the homocysteine levels come back high, homocysteine, as a marker when we're looking at it on blood work, it's actually an indirect marker for a deficiency of B12, folate, and vitamin B6. And actually, vitamin B2 plays a role in this, but in our next episode, we're going to dive into some more B vitamins. But folate, B12, and B6 all help to drive homocysteine down. Now, many of you have had methylation, DNA methylation testing done through companies like 23andMe, where you're looking at mutations in MTHFR genes and mutations in a gene called CBS, cystathione beta synthase, mutations in MTR, MTRR. These are additional genes where these three vitamins play a role in helping you to metabolize homocysteine. So some people have genetic mutations in those genes which put them at a disadvantage. You can still do this, but it's just harder for you to do it. And where that becomes a problem is if you're chronically sick and you have genetic mutations and it's harder for you to do this pathway, then you can get stuck being sick without supporting. So sometimes we need to support the methylation pathways with these B vitamins. Sometimes it's a very, very crucial part of helping somebody recover from a chronic illness. But yes, you can supplement. One of my favorite supplements actually to do this is a product called Hydroxocobalamin. And if you go online, if you go to glutenfreesociety.org and go to the shop, you can find it. It's Hydroxocobalamin. Its nickname is Methylate, like Kool-Aid, right? But Methylate, because it helps aid in the methylation pathway. So, but it contains all three. It contains B12, it contains methylated folate, and it contains vitamin B6 in a pyridoxal 5-phosphate form, which are the three best forms for the absorption and for the methylation aid in this process. And those of you who have high homocysteine, maybe you've been to your doctor and you've already had your homocysteine checked and it was high, and you're looking for a natural way to bring it down, you can pick up hydroxocobalamin, and if you use the coupon code ENERGY, you'll get $10 off of that if that's something that you're looking at trying. We like to take care of you here at Gluten Free Society on the Pick Dr. Osborne Brain Show by giving you things you can use and helping you save money at the same time. So let's see here. Tina's hi from Serbia. Wow, all the way from Serbia. Welcome, Tina. Could you have high blood numbers and low utility? Tina, I'm not sure I understand what you mean by that question. Maybe if you'll re-ask it in a different way, give me a little bit better clarity. If you mean high blood numbers of homocysteine but low utility, again, I'm not sure what you mean by that. You can have high blood numbers of homocysteine, but generally if you do, it's a problem with either a deficiency in one of these three or a genetic mutation in one of the genes that these three vitamins help to work, or it's a problem in your environment where you're being overexposed to things that would create an increased need for methylation and transsulfuration, which are detoxification pathways. So you're burning through more of your detoxification capacity, thus this is starting to go up. So not sure if I answered your question, but I'm not sure that I understood it either. Okay. So Ronnie's asking, so lower homocysteine is not good also. What is the optimal range for homocysteine? I like to see it between 6 and 9. Between 6 and 9 is a good range. Remember, homocysteine isn't evil or bad. It's just we don't want it too low, obviously, because if it's too low, we still have to get to these places, and we need this metabolite to be able to do that. But we also don't want it too high. So between 6 and 9 is quite ideal. Okay. Hi, Sophie. Sophie's chiming in and just saying hi. Tina is, I think, clarifying her question here. She asked earlier if you could have high blood numbers and low utility. Okay, she was referring to vitamin B12. So the answer to that is yes, and here's why. You can have really high serum vitamin B12 levels. Let's see, what are we going to do? Let's make some space. You can have really high serum levels of vitamin B12, and so this is your blood vessel, and you got high levels of B12 floating around in your blood vessel. B12 doesn't work in the serum. It works intracellularly. That's where it performs most of its jobs, its functions. So B12 has to navigate and enter the cell. So if this is a cell, so it has to go from your bloodstream and it has to get into the cell. And that's why a lot of times when people get their B12 levels measured, their levels in their bloodstream look normal, but their levels intracellularly are not. And it has to do with, is this happening? And one of the reasons we can get high serum B12 levels is when people inject or supplement with a lot of cyanocobalamin, which doesn't get into the cell as effectively. The methyl and the hydroxy forms are much more effective at getting the B12 into the cell, so where the actual work of what vitamin B12 is about actually takes place. So to answer your question, yes, you can have normal or even high levels of vitamin B12 in your blood and low utility, meaning you can have high levels, but you still act as if you're vitamin B12 deficient. That's why it's important when you get this tested, and you've heard me say this a number of times today, we want to test intracellular levels. We don't want to test serum levels. If we're measuring serum levels, we can get, one of the things that also happens here is the liver can redistribute. So the liver, as an organ, can push B12 out into the serum. Okay, so the liver stores B12, and when the system is low, the liver will redistribute stored B12 into the bloodstream. And again, if we're testing you on a time where your liver's doing redistribution, we can get an artificial elevation in your B12 levels, and of course that can be very misleading. So this is why we want intracellular levels, because that's where the vitamin B12 is actually doing its job and doing the work. So again, good question. Let's see what else we got here. Oh, Louise lowered her homocysteine from 11.9 to 6. You should tell us how you did it, Louise. Did you do it with B vitamins? Because one of the other things that can lower homocysteine effectively is something called SAMe, which is S-adenosylmethionine, which plays a role here. SAMe plays a role in this process. It also plays a role in the process of converting methionine into, there's a methylation reaction here. After methionine, there's a methylation reaction that involves something called SAMe, S-adenosylmethionine, and then that is actually what then leads to the transference of new protein and RNA and DNA. So again, SAMe can also be used. It can be very, very helpful. Okay. My Facebook keeps crashing on me, so be patient with me as I reload it. Here we go. Okay. So Tracy's asking how many MTHFR mutations. Oh, I don't know. I guess she's asking that to Louise. Never mind. I thought that was a question. All right. Well, my Facebook's not loading, so I'm not going to keep making you guys wait. But again, I wanted to share this information with you. Now that you have it, you can go to your doctor. You can ask for a couple different things. One, you can ask for him to measure your homocysteine levels, looking for that to be between 6 and 9. You can also ask him to measure your serum, not serum, but your intracellular folate, B12, and vitamin B6 levels to see which one, or if you need all three. Sometimes I see people with normal levels here, and it's really the major issue is vitamin B12. Sometimes it's folate, sometimes it's B6, sometimes it's 2 of the 3, sometimes it's all 3. And sometimes it's just a good idea to use a supplement that contains all 3 for balance. There are some studies that show if you take too much folate, you can actually cause a vitamin B12 deficiency, and vice versa. If you take too much B12 unassisted with folate, you can actually create a vitamin B12 deficiency. So again, taking them together, because they work as a team, can oftentimes be extremely, extremely helpful. So I hope you enjoyed this. Next time we're going to talk about the other B vitamins and some of their central roles and signs and symptoms of deficiency. So you've got to stay tuned. We're going to be talking about that on Monday. I will be back Monday before the 4th of July holiday. So we will see you on Monday. Those of you, again, who are new to the show, if you don't have your copy of No Grain, No Pain, you can pick that up at NoGrainNoPainBook.com. You can also find it at Barnes & Noble and Amazon. And those of you who found this information helpful, if you know somebody in your family who's struggling with any of these symptoms, please make sure you share it with them. As always, remember that our mission here at drpeterosborne.com is to help 100 million chronically sick people get better. And we can't do that without your help sharing this information with as many people that you love and care about, you think could find it beneficial. So have a great weekend. We will see you back on Monday. Good day.